When Delta Airlines Flight 191 landed at its scheduled destination on the evening of November 12, 1980, ground crew noticed something unusual during the standard post-flight inspection. The fuel gauges on the Boeing 727 showed readings that didn't align with the flight plan. According to the aircraft's fuel management system, the plane had consumed approximately 42 gallons less fuel than calculated for the flight profile. The discrepancy was minor enough to be attributed to instrument error or favorable winds. But when maintenance technicians cross-referenced the fuel logs with the departure readings taken at the origin airport, they discovered something that violated basic principles of aviation physics. The aircraft had reportedly burned less fuel than required just to taxi and reach cruising altitude. The flight had departed LaGuardia Airport at 6:47 in the evening, bound for Minneapolis-St. Paul International Airport. It was a routine service, operated 3 times weekly, covering a distance of approximately 1,020 nautical miles. The weather was clear across most of the route, with light headwinds forecast at cruising altitude. Captain Robert Hendricks had logged over 14,000 hours, including 9,000 on the 727. His first officer, Michael Torres, had 6,200 hours. The flight engineer, David Coleman, was responsible for monitoring fuel flow, engine performance, and all onboard systems throughout the flight. The 727 that night was a Series 200 model, registration number November 73 Delta Tango. It had entered service in 1974 and maintained a clean maintenance record. The aircraft was equipped with 3 Pratt & Whitney JT8D turbofan engines and carried standard avionics for the era, including a Bendix weather radar system and dual VHF communication radios. Maximum fuel capacity was 8,090 gallons distributed across 4 main tanks and a center tank. For the Minneapolis flight, the aircraft was loaded with 6,200 gallons, which provided adequate reserves for the planned flight time of 2 hours and 18 minutes, plus the required 45-minute reserve. At 6:32, Captain Hendricks received clearance to taxi from Gate 12. The aircraft pushed back without incident. Ground control directed them to runway 4 via taxiways Alpha and Bravo. During taxi, the flight engineer noted fuel flow readings consistent with ground operations. At 6:47, the tower cleared Delta 191 for takeoff. The aircraft rotated at 140 knots and climbed out on a heading of 320 degrees. New York Departure Control handed them off to Boston Center at 7,000 feet. The flight was instructed to climb to flight level 350 and proceed direct to the Carmel VOR, then follow airway Victor 146 toward Chicago airspace. At 7:03, the aircraft leveled at 35,000 feet. Airspeed stabilized at 460 knots. Fuel flow across all 3 engines read within normal parameters. The flight engineer recorded the readings in the log. Engine 1 at 2,100 pounds per hour, Engine 2 at 2,200 pounds per hour, Engine 3 at 2,100 pounds per hour. Total fuel remaining was calculated at 5,800 gallons. These numbers match the flight plan projections within acceptable margins. At 7:19, Cleveland Center cleared Delta 191 to proceed direct to the Badger VOR, cutting approximately 6 minutes off the route. Captain Hendricks acknowledged, and the first officer dialed the new waypoint into the flight management system. The aircraft turned slightly north. Outside air temperature at altitude was minus 54 degrees Celsius. Winds were recorded at 20 knots from 270 degrees. The cabin was pressurized to the equivalent of 7,000 feet. All passengers were seated. The seatbelt sign had been turned off 12 minutes after departure. At 7:38, Cleveland Center handed the flight off to Chicago Center. The controller assigned them a frequency of 124.65. First Officer Torres made contact and confirmed their altitude and position. Chicago Center acknowledged and instructed them to maintain flight level 350. There was moderate traffic in the sector that evening, including two other commercial flights and one military transport operating under visual flight rules at a lower altitude. Radar showed Delta 191 as a clean primary and secondary return, transponders squawking the assigned code of 4712. It was at 7:41 that the first irregularity appeared, though it would not be recognized as such until much later. The controller handling Delta 191's sector noted in his log that the aircraft's radar return momentarily disappeared from his screen. The loss of contact lasted between 4 and 6 seconds. This was not unusual in itself. Radar coverage in that region occasionally experienced brief gaps due to terrain masking or equipment switching between ground stations. The controller made a written note but did not query the flight. The transponder return reappeared without interruption to the data block showing altitude, speed, and heading. Aboard the aircraft, none of the crew reported any awareness of a discontinuity. The flight engineer's log shows continuous entries at regular intervals. At 7:42, he recorded fuel remaining at 5,100 gallons. Fuel flow remained stable. Engine instruments showed normal exhaust gas temperatures, N1 and N2 compressor speeds, and oil pressures. There were no caution lights, no anomalous vibrations, and no deviations from the flight plan. The autopilot was engaged and maintaining the assigned altitude and heading with no input from the crew. At 7:56, Chicago Center cleared Delta 191 to descend to flight level 240 in preparation for the arrival into Minneapolis. Captain Hendricks acknowledged and began a standard descent at a rate of 1,500 feet per minute. The flight was now approximately 230 nautical miles from the destination. Estimated time of arrival remained on schedule for 9:05 local time. The weather at Minneapolis was reported as clear skies, visibility 10 miles, winds light and variable. Runway 30 left was in use for arrivals. At 8:14, Minneapolis Approach Control assumed radar contact and issued vectors for a visual approach. The flight was cleared to descend to 10,000 feet and given a heading of 085 degrees to intercept the extended centerline for runway 30 left. First Officer Torres extended the speed brakes to increase the rate of descent. Airspeed was reduced to 250 knots to comply with regulations below 10,000 feet. The flight engineer noted fuel remaining at 3,200 gallons. Fuel burn to this point had been consistent with the flight plan, accounting for the slightly shorter routing and the descent profile. At 8:27, the aircraft was cleared for a visual approach. Captain Hendricks disengaged the autopilot and flew the final segment manually. The landing gear was extended at 8:29. Flaps were set to 15 degrees, then 25 degrees as the aircraft descended through 1,500 feet. Airspeed was 145 knots on final. The aircraft crossed the threshold at 8:32 and touched down smoothly on the centerline. Reverse thrust was applied, and the aircraft decelerated normally. It exited the runway at taxiway Charlie and was directed to gate 7 by ground control. Captain Hendricks set the parking brake at 8:36. The engines were shut down in sequence. The flight engineer completed the shutdown checklist and recorded final fuel readings. According to the fuel quantity indicators, the aircraft had 2,950 gallons remaining in the tanks. The flight time from takeoff to landing had been 1 hour and 45 minutes. Based on the loaded fuel of 6,200 gallons and the remaining fuel, the aircraft had consumed 3,250 gallons during the flight. This is where the inconsistency emerged. According to Delta's performance data for a 727 on that route, at that weight, and under those wind conditions, expected fuel consumption should have been approximately 3,600 gallons, accounting for taxi, takeoff, climb, cruise, descent, and landing reserves. The difference of 350 gallons was significant, but not unprecedented. Favorable winds, efficient cruise altitude, and a reduced flight time could account for lower than planned fuel burn. The flight engineer noted the discrepancy, but filed the flight log without flagging it as unusual. It was only when the fueling crew arrived to service the aircraft for its next leg that the anomaly became more pronounced. The fuel truck operator used a calibrated dipstick to physically measure the fuel in each tank before adding fuel for the return flight. His measurements showed that the aircraft held 3,040 gallons, 90 gallons more than indicated by the cockpit gauges. Gauge error was common, and a variance of 1 to 2% was considered normal. But the operator also reviewed the departure fuel logs from LaGuardia. Those logs, which had been recorded by a different fueling crew and cross-checked by the flight engineer before departure, indicated that the aircraft had been loaded with 6,200 gallons. The operator performed a calculation. If the aircraft departed with 6,200 gallons and now held 3,040 gallons, total consumption was 3,160 gallons. That was nearly 500 gallons less than the flight plan estimate, and almost 90 gallons less than what the cockpit gauges had indicated as consumed. The operator mentioned the discrepancy to the ground supervisor, who logged it in the station maintenance record as a potential fuel gauge calibration issue. The aircraft remained in service. The following morning, a Delta maintenance technician was assigned to inspect the fuel gauging system. He ran diagnostic tests on the fuel quantity probes in each tank and found them functioning within specification. He checked the wiring harnesses and the fuel control panel. No faults were detected. He then reviewed the previous day's flight logs and noticed that the discrepancy was specific to the Minneapolis flight. Prior flights showed normal fuel consumption patterns. He recommended monitoring the system on subsequent flights, but did not ground the aircraft. Over the next 2 weeks, November 7-3 Delta Tango completed 16 additional flights. Fuel consumption on all of these flights matched expected performance data within standard margins. The gauging system reported accurately. There were no further anomalies. The incident from November 12th was logged as an isolated event, likely the result of a momentary gauge malfunction or a recording error during fueling at LaGuardia. However, 3 months later, a routine audit of Delta's fuel management records flagged the November 12th flight for review. The airline's fuel efficiency program tracked consumption across the fleet to identify aircraft that consistently burned more or less fuel than the fleet average. November 7-3 Delta Tango had shown a statistical outlier on that single flight. An analyst requested copies of the original fueling logs, the cockpit fuel log, and the post-flight inspection report. When the documents were compiled, the analyst noticed an additional irregularity that had been overlooked. The fueling log from LaGuardia, signed by both the fueling operator and flight engineer Coleman, recorded a fuel load of 6,200 gallons at 6:18 in the evening. The aircraft's logbook recorded engines start at 6:32. 14 minutes had elapsed. During that time, the auxiliary power unit, which provides electrical and pneumatic power on the ground, would have been running. The APU consumes approximately 30 gallons of fuel per hour. For 14 minutes of operation, expected consumption was roughly 7 gallons. Yet the flight engineer's logbook showed no adjustment for APU fuel burn. His initial in-flight fuel reading at engine start was recorded as 6,200 gallons, identical to the fueling log. This suggested one of two possibilities. Either the flight engineer had failed to account for APU consumption, which would constitute a minor procedural oversight, but would not explain the overall low fuel burn during the flight, or the aircraft had somehow not consumed fuel during ground operations, despite the APU running, which was physically implausible. The analyst cross-referenced the departure time logged by the flight crew with air traffic control recordings archived by the FAA. The tapes confirmed that Delta 191 had been cleared for takeoff at 6:47, which matched the crew's logbook, but the initial contact with New York departure, which should have occurred within 1 to 2 minutes of takeoff, was logged at 6:49. The flight had been airborne for 2 minutes before making radio contact, which was longer than standard but not a violation. The analyst expanded the review to include radar data archived by the FAA's en route facilities. Cleveland Center and Chicago Center maintained recordings of all radar tracks for 60 days before transferring them to long-term storage. The tapes from November 12th were requested. When they arrived, the analyst reviewed the recorded track of Delta 191 from Boston Center's handoff to Cleveland Center at 7:03 until Minneapolis approaches assumption of control at 8:14. The track showed a continuous flight path with no interruptions. The aircraft's transponder reported altitude and ground speed at regular intervals. There were no gaps in the data, but there was something unusual in the timing. According to Cleveland Center's radar logs, Delta 191 checked in on frequency at 7:19 and was cleared direct to the Badger VOR at 7:19 and 12 seconds. The flight acknowledged, and the radar track showed the aircraft beginning its turn to the new heading at 7:19 and 35 seconds. This was a normal response time. However, Chicago Center's logs indicated that Delta 191's first radar return in their airspace appeared at 7:38 and 14 seconds, exactly as expected, based on the aircraft's speed and position. But the controller's handwritten log entry noted that the aircraft's transponder return had briefly dropped off the screen at 7:41 and reappeared 6 seconds later. The analyst requested the radar tape for that specific segment. The FAA provided a digital copy of the archived data. The tape showed Delta 191's transponder signal as continuous except for a single dropout lasting 5.8 seconds, beginning at 7:41 and 18 seconds, and resuming at 7:41 and 23.8 seconds. During the dropout, no primary radar return was recorded either. This meant that for nearly 6 seconds, the aircraft was not visible on radar at all. The controller had noted the dropout but had not queried the flight because the transponder return resumed immediately and all displayed parameters were normal. The analyst contacted the controller, who had since transferred to a different facility. The controller confirmed his recollection. He remembered the brief loss of contact, but said it had not been cause for concern. Radar dropouts occurred periodically, particularly in areas where coverage transitioned between ground stations. He had not issued a radio call to the aircraft because the return had reappeared before he could key his microphone. He did not recall any unusual characteristics about the flight. When asked if the aircraft's position upon reappearance had matched its projected track, he said he had not specifically checked. The data block resumed in the expected location, so he assumed continuity. The analyst performed a more detailed examination of the radar data. Using the recorded ground speed and heading prior to the dropout, he calculated where the aircraft should have been when the transponder return resumed. According to his calculations, based on a ground speed of 460 knots and a heading of 315 degrees, the aircraft should have traveled approximately 0.74 nautical miles during the 6-second gap. When he measured the distance between the last recorded position before the dropout and the first recorded position after, the displacement was 0.68 nautical miles. The difference of 0.06 nautical miles, approximately 360 feet, was within the margin of error for radar accuracy at that range and altitude. However, the analyst also noted that the aircraft's ground speed after the dropout was recorded as 463 knots, 3 knots faster than before. This could be explained by minor wind shifts or slight changes in thrust settings, but it added another small data point to the overall pattern of irregularities. The analyst compiled a summary report and submitted it to Delta's Flight Operations Division. The report outlined the fuel discrepancy, the radar dropout, the minor inconsistencies in timing and fuel logs, and the absence of any mechanical explanation. The report recommended a formal review of the flight data recorder and cockpit voice recorder tapes from the flight, if they were still available. However, in 1980, flight data recorders on 727 aircraft captured only 5 parameters: time, altitude, airspeed, heading, and vertical acceleration. They did not record fuel flow, engine performance, or navigation data, The recorders used physical foil tape that was overwritten after 25 hours of flight time. By the time the analyst's report was filed in February of 1981, the recorders from November 7-3 Delta Tango had been overwritten more than 100 times. The cockpit voice recorder, which captured the last 30 minutes of audio from the flight deck, had also been overwritten. Standard procedure was to preserve CVR and FDR data only in the event of an accident or serious incident. Since Delta 191 had landed without incident and no abnormalities had been reported by the crew, the recorders had continued to operate normally on subsequent flights. No audio or detailed flight data from November 12th remained available for analysis. Delta's Flight Operations Division reviewed the analyst's report and consulted with the FAA. The FAA reviewed the radar data and confirmed the 6-second dropout, but noted that such events were not uncommon and did not indicate any safety issue. The FAA's position was that without physical evidence of a mechanical failure or a crew report of an anomaly, there was insufficient basis to launch a formal investigation. Delta's internal review reached a similar conclusion. The fuel discrepancy was noted as a possible gauge error, or fueling log inaccuracy. The radar dropout was classified as a normal artifact of radar coverage transition. The flight was closed without further action, but the analyst was not satisfied. He requested permission to interview the flight crew. Delta's chief pilot approved the request. In March of 1981, the analyst met separately with Captain Hendricks, First Officer Torres, and Flight Engineer Coleman. All 3 crew members were still employed by Delta and flying regular schedules. Captain Hendricks recalled the flight clearly. He described it as entirely routine. Weather had been good, the aircraft had performed normally, and there had been no mechanical issues. When asked if he had noticed anything unusual during the flight, he said no. When the analyst mentioned the radar dropout at 7:41, Hendricks said he had no awareness of it. The flight had been smooth, the autopilot had been engaged, and there had been no interruption in radio communication. When asked about fuel consumption, Hendricks said he had not personally reviewed the post-flight fuel readings. That was the flight engineer's responsibility. He trusted Coleman's entries in the log. First Officer Torres also described the flight as routine. He confirmed that the autopilot had been engaged for most of the cruise phase and that he had not noticed any irregularities. When asked specifically about the time period around 7:41, he said he did not recall anything unusual. He mentioned that he had been reviewing the arrival procedures for Minneapolis at that time, and his attention had been inside the cockpit rather than on the instruments. When asked if there had been any radio communication with Chicago Center at that time, he reviewed his notes and confirmed that the handoff from Cleveland had occurred just before 7:41, and that Chicago Center had not issued any further instructions until later in the flight. Flight Engineer Coleman provided the most detailed responses. He confirmed that he had recorded fuel quantities at regular intervals throughout the flight, and that all readings had been within expected parameters. When the analyst showed him the post-flight discrepancy between the cockpit gauges and the physical fuel measurement, Coleman said he had been aware of it at the time. He had noted it in his log and mentioned it to the fueling supervisor in Minneapolis, who had told him it was likely a gauge calibration issue. Coleman said he had checked the fuel gauges during subsequent flights and they had performed normally. He saw no reason to suspect anything more than a minor instrument error. When asked if he had noticed anything unusual during the flight itself, Coleman paused. He said that at one point during the cruise he had felt a brief sensation of disorientation, as though he had momentarily lost his sense of time. He described it as similar to the feeling of nodding off for a split second and then snapping back to alertness. He checked his watch and looked at the chronometer on the panel and saw that no time had passed. He assumed it was fatigue. He had been awake since early morning and had operated 2 flights before Delta 191. He did not mention the sensation to the other crew members at the time because it had been so brief and he had felt fine immediately afterward. The analyst asked Coleman what time this sensation had occurred. Coleman referred to his logbook and said it had been shortly after 7:40, based on his next fuel log entry at 7:42. The analyst asked if he had been looking at any specific instrument when it happened. Coleman said he had been scanning the engine instruments and the fuel panel, which was his standard scan pattern. He had not noticed any change in the readings. Everything had appeared normal before, during, and after the brief moment of disorientation. The analyst asked if anyone else on board had reported anything similar. Coleman said he did not know. He had not discussed it with the captain or first officer, and no passengers or flight attendants had mentioned anything unusual. The analyst asked if Coleman would be willing to review the passenger manifest and contact information to see if any passengers could be interviewed. Coleman said he did not have access to that information, but the analyst could request it from Delta's customer service division. The analyst submitted a formal request for the passenger manifest. Delta's legal department denied the request, citing passenger privacy. The analyst appealed, explaining that he was attempting to corroborate a reported anomaly that might have safety implications. The legal department responded that without evidence of a safety incident, there was no justification for contacting passengers. The analyst was advised to close the review. Instead, the analyst filed a report with the National Transportation Safety Board, outlining the fuel discrepancy, the radar dropout, and flight engineer Coleman's statement about the brief disorientation. The NTSB reviewed the report and determined that it did not meet the criteria for an incident requiring investigation. The NTSB's definition of an incident includes events involving significant aircraft damage, serious injury, or situations that compromise safety. A fuel discrepancy and a 6-second radar dropout, absent any crew report of an emergency or any physical evidence of malfunction, did not meet the threshold. The NTSB filed the report in its database, but took no further action. The analyst made one final attempt. He contacted the FAA's Technical Center in Atlantic City, New Jersey, which specialized in air traffic control systems and radar performance. He sent a copy of the radar data from November 12th and asked if the 6-second dropout could be analyzed in more detail. The FAA Technical Center assigned an engineer to review the data. The engineer's report concluded that the dropout was consistent with a loss of transponder signal and primary radar return due to either atmospheric conditions, equipment malfunction at the ground station, or a brief electrical fault aboard the aircraft. The engineer noted that the timing of the dropout at 7:41 and 18 seconds corresponded to a point where the aircraft would have been at the edge of Cleveland Center's radar coverage and at the beginning of Chicago Center's coverage. It was possible that both ground stations had temporarily lost contact during the handoff transition. The engineer found no evidence of anomalous aircraft behavior based on the data. The analyst had exhausted all available avenues. He filed a final memo in Delta's records and moved on to other projects. The November 12th flight of Delta 191 became a footnote in the airline's operational history, referenced only as an example of the challenges in reconciling fuel management data across multiple sources. But the story did not end there. In 1996, a retired air traffic controller named Gerald Moss was interviewed for an oral history project conducted by the FAA. Moss had worked at Chicago Center from 1977 until his retirement in 1988. During the interview, Moss was asked if he had ever experienced anything during his career that he could not explain. He mentioned a single event, which he said had stayed with him. He described a flight in 1980. He could not recall the exact date, which had briefly disappeared from his radar scope. When it reappeared, the flight had continued normally, and he had not reported it because the incident seemed minor. But he said that years later, when he reviewed his old logbooks out of curiosity, he noticed that he had written a note next to the entry. The note read, 6 seconds, no contact, no call. He said he did not remember why he had written it in that specific way, but it suggested to him that the dropout had felt significant at the time. The oral history interview was archived in the FAA's library and remained there until 2004, when a researcher studying air traffic control procedures in the 1980s came across it. The researcher noted the reference to a radar dropout and attempted to identify the flight Moss had been describing. Using the date range Moss provided, the researcher cross-referenced Chicago Center's logs for flights that had experienced brief radar dropouts. There were dozens of such events in any given month, but when the researcher filtered for flights where the controller had made a specific written note, only a handful remained. One of them was Delta 191 on November 12, 1980. The researcher contacted the analyst who had originally compiled the report in 1981, but by that time the analyst had retired and could not be located. The researcher then requested the archived radar data and the original fuel logs from Delta. The radar data was available from the FAA, but Delta no longer retained operational records from flights that had occurred more than 20 years prior, unless those flights had been involved in accidents or significant incidents. The fuel logs were gone. The researcher published a paper in 2006 in a Journal of Aviation History titled Unexplained Discontinuities in Flight Data, Case Studies from the 1980s. The paper discussed several flights, including Delta 191, where minor data anomalies had been recorded but never fully investigated. The paper did not propose any explanations. It simply documented the incidents as examples of the limitations of flight data recording and analysis during that era. In 2012, the paper was referenced in an online forum dedicated to aviation mysteries. A commenter noted that the fuel discrepancy on Delta 191 was consistent with the aircraft having flown for approximately 6 fewer minutes than the recorded flight time, assuming standard fuel burn rates. 6 minutes corresponded to a distance of approximately 46 nautical miles at cruising speed. Another commenter pointed out that 6 seconds was the duration of the radar dropout. A third commenter suggested that the two anomalies might be related, though no mechanism was proposed. A former Delta pilot who had flown 727s in the 1980s joined the discussion. He noted that fuel gauging systems on the 727 were generally reliable, and a discrepancy of several hundred gallons would have been immediately noticeable to the flight engineer. He also noted that if the aircraft had somehow covered less distance than expected, the crew would have noticed a significant deviation in their navigation instruments. The VOR receivers, the inertial navigation system if installed, and the visual cross-checks with ground landmarks would all have indicated the aircraft's position. There was no mention in the crew interviews of any navigation discrepancies. The discussion continued sporadically over the years, with occasional new participants offering theories. Some suggested that the fuel logs had been incorrectly recorded at both LaGuardia and Minneapolis. Others proposed that the radar dropout had been longer than 6 seconds and that the recorded time was in error. A few speculated about atmospheric phenomena that might have affected both fuel burn and radar detection, though no specific mechanism was identified. The consensus among most participants was that the incident, while unusual, likely resulted from a combination of minor procedural and instrument errors that had been compounded in the records. In 2019, a Freedom of Information Act request was filed with the FAA, seeking any additional documents related to radar anomalies on November 12, 1980. The FAA responded that all relevant documents had already been released and were part of the public record. However, the response included a previously unreleased memo from the FAA Technical Center dated December 1980, which had been filed in error under a different case number. The memo was a follow-up to the engineer's report on the radar dropout. It noted that during a review of the ground station equipment logs, a brief power fluctuation had been recorded at the Chicago Center radar site at 7:41 on November 12th. The fluctuation had lasted less than 1 second and had been attributed to a voltage spike in the local power grid. The memo concluded that the power fluctuation could have caused the radar equipment to reset, resulting in the loss of contact with Delta 191. However, the memo also noted that the radar system's backup power supply should have prevented any interruption in coverage, and it was unclear why both the primary and secondary radar had had lost contact simultaneously. The memo did not change the overall conclusion, but it added one more detail to a picture that had never fully resolved. An aircraft had flown from New York to Minneapolis and arrived with less fuel consumed than the flight should have required. The fuel discrepancy could not be definitively attributed to gauge error because multiple independent measurements had confirmed it. The aircraft had briefly disappeared from radar at the midpoint of its flight, and no technical explanation fully accounted for the loss of both primary and secondary returns. A member of the flight crew had experienced a momentary disorientation at approximately the same time, though he had not reported it as significant. And the flight had arrived on schedule, with no awareness among the crew or passengers that anything unusual had occurred. Every individual element of the incident had a plausible, mundane explanation, but when taken together, the explanations did not fit as neatly as they should. The fuel that was not burned had to have gone somewhere, or the aircraft had to have flown more efficiently than the laws of thermodynamics would predict. The radar return that vanished had to have been caused by something, either aboard the aircraft or on the ground, yet both the aircraft systems and the ground equipment had tested normally. The flight engineer's sensation of lost time had to have been fatigue or a trick of perception, yet it occurred at the exact moment when the radar lost contact. There is no official conclusion to the case of Delta Flight 191 on November 12, 1980, because there was never an official case. The flight completed its journey without incident. The crew went on to fly thousands more hours. The aircraft remained in service until it was retired from the Delta fleet in 1991. The passengers arrived at their destinations and went on with their lives. And the records, incomplete and contradictory as they are, remain filed in archives, accessible to anyone who knows where to look. What is known is this. For 6 seconds on that November evening, an aircraft carrying 137 people ceased to exist on radar, and when it landed, it had burned fuel as though those 6 seconds, or perhaps 6 minutes, had never happened. The flight crew noticed nothing. The passengers noticed nothing. The systems aboard the aircraft recorded nothing. But the numbers, cold and precise, tell a different story. They suggest that for a brief, unaccounted period of time, the aircraft was not where it was supposed to be, or that time itself had not passed in the way it should have. No one aboard Delta 191 that night was harmed. No one reported fear or confusion. The flight is remembered by those who were on it, if it is remembered at all, as entirely ordinary. But the data, reviewed and re-reviewed over decades, resists a simple explanation. It sits in files and databases, a small collection of inconsistencies that refuse to resolve. And perhaps that is where it will remain, a question without an answer, a flight that ended exactly where it was supposed to, with fuel that should not have been there. If you follow aviation mysteries and unexplained incidents, subscribe for future investigations.